Hey everybody, my name is Jason Kemris and I'm the superintendent of Richmond Public Schools, and I'm so excited to kick off my daily math lessons. Before I do so, I just wanted to say thank you so much to the entire Richmond community for all that you have done to wrap your hands and your love around RPS. We are just so incredibly grateful. It's unlike anything I've ever seen before. And so from the bottom of my heart, I just want to say thank you to everyone who has pitched in. There's obviously a lot of uncertainty and some hard days ahead, but I do believe that together we'll come out the other side even stronger. And that's why we've started using the hashtag RPS Strong, and I encourage you to do so on social media. A few notes before we get started, and I'm going to look at my notes on the side here because I did some prep, as good teachers do. First, I just wanted to check in on any students that are watching right now. Wanted to let you know, I know this is kind of a crazy time and uncertain time, and it might even be a little bit scary, but I want you to know that we're going to do everything we can at Richmond Public Schools to support you, and that we're here for you and we love you very much. I also want to just check in on our families, our caregivers. I know this is incredibly stressful for you, and many of our families, many of you watching today probably struggle on a day-to-day basis just to make ends meet. And now with all of this new challenge facing us, things have gotten even harder. And so please know we're going to do everything we can to support you, make sure your families have food, if we can, connect you with childcare, and of course provide academic resources for you and your family to continue learning. But I know it's a very, very difficult time. And so if there is anything else that we can do at RPS, please keep emailing me, letting me know so that we can continue to be supportive. My email is jkamras, K-A-M-R-A-S, @rvaschools.net. And last, to our staff, thank you so much. You guys have just pitched in so many different ways. I've been watching what teachers are doing by posting videos and doing FaceTime chats and creating resources and even dropping off food at kids' homes. It's been so inspiring, and it just makes me even prouder to be your colleague. And on behalf of the entire school system, thank you. Thank you to our teachers, our counselors, our custodians, our nutrition staff, everybody. You've all just been incredible. So with that, let's get started. I have a little sign to kick us off. And here it is. And I have to, oh, wait. There it is. Mr. K's 30 minutes of math. And I even have a sound effect. That is, all credit goes to my two boys, Ezra and Akiva. Thank you so much for making the sign and for lending your sound machine, which has all kinds of interesting sounds on it. I appreciate them. And I also have to give a shout out to my wife, who's made it possible for me to do so much with and for the RPS community, not just this week, but over the last couple of years. So big shout out to both of them. A few disclaimers before we get started. First, it's been a little while since I've been a regular teacher. Here you go. That is me back in the day in my classroom in Washington, D.C. I had much less gray back then, but I gotta say I love teaching, and part of me is super excited to be able to do this every day and get back to my roots. The other part of me is super freaked out, so bear with me as I get back in the saddle, as it were. But look, when I was a teacher, I was super serious about it, as you might imagine. And so here's a math portfolio from my classroom from back in the day, for one of my extraordinary students, Michelle, who actually went on to become an instructional assistant. So super proud of her. Another disclaimer, it occurs to me I do not have a teaching license in the state of Virginia. So I'm gonna ask for Dr. Lane's grace on that one, but I do have this thing. So hopefully that gives me a little bit of license to teach here in Virginia. Now a word about the math curriculum that we're using. It's different from how I think most folks were taught math. And so I know that causes some uncertainty and some struggle. But what I wanted folks to know is that the struggle is really helpful. That means that folks are stretching their minds and learning new things. And the point of this curriculum is so that our kids have a deep understanding of their math, not just be able to memorize rules and then regurgitate answers. Not saying getting the right answer isn't important, but we want kids to understand how they got those answers and why the rules are what the rules. So I'm going to give you an example just to kick us off. So I want everybody to, I have my whiteboard, I got my markers. Okay, so I want everybody to take a second, and I'm going to actually put a sign up to give you a little bit of time to work on this. I want you to think of a word description or a picture or a story that explains the answer for 2/3 times 3/4. So I know folks adults who went through school or older kids know the rule, which is you multiply the numerators and you multiply the denominators, which would give you 6/12, which is can be simplified to 1/2. Great. But I want someone to explain to me why 2/3 times 3/4 is 1/2. Explain to me in a picture, explain to me in a story. Obviously, you're not gonna be able to show it to me, but I'm gonna give you 2 minutes to do that work with whoever is around your table, around your computer right now, and then we'll come back and talk about it. And so while you're working, I have this little screen to put up, and let's see if I can make this work. Here we go. Take 2 minutes. Thank you. All right, let's come back, and hopefully some of you came up with some really good stories or really good drawings. I want to try to make it as simple as possible to help folks wrap their heads around what does it mean to do 2/3 times 3/4. So I'm going to start with the 3/4 part of this, and I'm going to use something which is very familiar to adults and to kids, and that's money. So 3/4, 3/4 of a dollar is 3/4. Make sense? 3/4 of a dollar is 3/4. So the question is, how do we take 2/3 of the 3/4? So 2/3 means we need to have 3 equal parts, and we're going to take 2 of them. That's 2/3, 2 of the 3 equal parts. If we add these together, 25 cents and 25 cents is It's hard to write this way. 50 cents. 50 cents is half of a dollar. So there you go. 2/3 times 3/4 is 1/2. Now you can understand how you actually got there without just doing the algorithm, which of course is important, but we also want folks to understand exactly what is going on. A couple more things about what we're going to do here. I'm going to focus on 4th grade Unit 5 in our curriculum because that's roughly where 4th graders are in the year if we were in school. And if you are in 3rd grade or 2nd grade or 5th grade, 6th grade, whatever, and you're interested, of course, we invite everyone to participate and be a part of the learning. So with that, I'm gonna say, almost get started. The focus of this set of lessons is decomposing fractions. That's a fancy way of saying breaking them up. Looking at equivalent fractions, so those are fractions that are the same. And then comparing and ordering fractions. So which is larger, which is smaller, and putting them in order from smallest to largest and vice versa. So that's the focus of this unit. I'm going to actually use the real curriculum and work our way through the lessons. Obviously 30 minutes is not enough to do everything we would do every day, but I am going to use it and work our way through it. I will make sure to post the resources from the lesson on our website and make them easily accessible for you as well, but today I'll show them on the screen. Also, you need, if you didn't already realize it, you need paper and something to write with also to get rolling. So with that, let us get started. I'm gonna look at the very first problem in this lesson, and I'm gonna pull it up here now. One second. Okay, so this is what's called a tape diagram. That's this part up here where you see the shaded strip. Down here is a number sentence where you see a more traditional equation. And then on the bottom right is number bonds. That's another way of representing how we compose and decompose numbers. You don't have to just do it with fractions. You can do it with whole numbers or any others as well. These are 3 different ways of representing numbers in our curriculum, and we like to use these visual representations, sometimes visual, sometimes straight with the numbers as in the equation, to help foster student understanding about actually what's going on. And so what you have here is a couple of things going on. The first is you'll see with the tape diagram that they clearly articulate what the whole is in this problem. And that's really important. In fractions, we talk about the whole and then the parts. So let me draw this up on the whiteboard. So what they're articulating here is this strip is the whole. Now that's really important to know what we are defining as the whole, because that then determines what defines the parts. So here, this is one whole, and we have 3 equal parts. And that's also really important, equal parts. Sometimes you will see kids, adults, just kind of go quick and they'll draw it like this. That is not accurate. It has to be equal parts for us to have an accurate understanding and representation of the number. So we have 3 equal parts, or as equal as I can draw them. We have the one whole, and because there's 3 parts, each of those parts is 1/3 of the whole. So each of those parts is 1/3 of the whole. And we can do our number sentence, which would be 1 equals 1/3 plus 1/3 plus 1/3. So again, one whole split into 3 equal parts gives us 1/3 plus 1/3 plus 1/3, and that gives us our whole. You can also do it in a number bond, another way of looking at it. Again, 1 whole, and then we have 3 parts, 1/3, 1/3, 1/3. And what you'll find is different kids like different representations. I really like the number bonds. I also like the tape diagrams. So that is a little bit of a primer in how we represent the numbers for this unit. I'm going to go on to the next problem and illustrate that. And then I'm going to give you some independent practice time to try to do it on your own. So let me go ahead and share the screen and get our problems back up. And we are going to pull up. All right, I'm going to do B now. And so what we're representing, what we want to be able to show is what the shaded part is representing. The shaded part. So I'm going to work on B right here. It's in the top right. And I will now switch back so that we can talk about it together. Okay, so again, here's the whole. And this time, and I'm going to use another color because I've got them here and I'm excited about it. This time there are 5 equal parts, if you notice. So I'm going to do my best. 1, 2, 3, 4, 5. Now, by the way, one other little note. Sometimes what you see is people will do this. If there's 5 parts, they draw 1, 2, 3, 4, 5 lines. That does not give you what we're looking for. We want 5 parts. We draw 5 lines, we get 1, 2, 3, 4, 5, 6 parts. So let's take that off. Okay, we have 5 equal parts, and if you'll notice, 4 of them are shaded. 1, 2, 3, 4. And then what it asks for is, you'll see there's a little bracket on the bottom there and a little bracket on the bottom there. So what that is showing is they want us to represent what part is shaded using this bracket and this bracket as our different pieces of the overall part that is shaded. So the first thing we have to just get clear on is how much is each of these parts. Remember, this is the whole. And we have 1, 2, 3, 4, 5 parts, which means we have a 5th here, a 5th here, a 5th here, a 5th here, and a 5th there. 5 fifths makes 1 whole. 1, 2, 3, 4, 5. Now the question is, how much is represented by the shaded part? Well, let's look at this bracket here. It's covering just this first square, so we know that's 1/5. This next bracket is spanning 1, 2, 3 fifths. Again, this bracket is spanning 3 fifths. 1, 2, 3. This bracket is spanning 1/5, so we know that's 1/5. So we know then that the entire shaded area, if we were to do a number sentence, is 1/5 plus 3 fifths, which gives us 1, 2, 3, 4 fifths. So 1/5 plus 3 fifths gives us 4 fifths. Another way you could do it is, if you like the number bonds, 4 fifths. And we know the first bracket is 1/5. And the second bracket is 3 fifths. Sorry, that's a little bit small. Again, showing that 4 fifths in this case is made up of 1/5 and 3/5. Okay, now what I'd love for you to do is create the number bond and the number sentence for C and D, and I'll put those up right now. Let's see if I can successfully do that. There they are. So C and D, take a couple of minutes to work on those. I see my clock says 2:20, so I'll come back at 2:22 and see how folks did. Okay, it looks like it is 2:22, so I'm gonna bring us back. And let's start with C. Again, we have one whole, and if you look, it is split up into 4 equal parts. So that tells us, now normally I would ask kids, what does that tell us? So I'm gonna do more of a voiceover than I would normally like to, and I'll figure out the question and answer thing tomorrow. But that would give us fourths. So 1/4 here, 1/4 here, 1/4 here, and 1/4 there. And we see that these parts are shaded. So the question is, what would be the number sentence and what would be the number bond to show what part is shaded? So we have 1/4 here, another one here, and another one here. 1, 2, 3. So 3/4 equals 1/4 plus 1/4 plus 1/4. And we're going to leave this one off. You could also show that in a number bond. 3/4, 1/4, 1/4, 1/4. 3/4 is 1/4 plus 1/4 plus 1/4. I know to the fraction pros out there that may seem elementary, but grasping that understanding that 3/4 can be decomposed, can be broken up into 1/4, 1/4, and 1/4 is really important as we get later on into equivalent fractions, into comparing fractions, and then ultimately to adding and subtracting, multiplying, dividing. All right, that was C. Let's look at D. So again, we have one whole, And let's see, we have 6 parts, 6 equal parts. Those aren't super equal, but I hope you'll forgive me. We have 6 equal parts, so each part is 1/6. Six equal parts, 1/6, 1/6, 1/6, 1/6, 1/6, 1/6. 6/6 gives us 1 whole. And we see here that 4 of them are shaded. 1, 2, 3, 4. And so the question is, what is, again, a number sentence or a number bond that would show us the part that is shaded? So if we were doing a number sentence, we would know that, well, we have 1, 2, 3, 4 that are shaded. That means we have 4/6 that are shaded all together. But, good teaching moment, I just realized they have 2 brackets, and we have to show those brackets to show a different way of putting this together. Those are their brackets. And you can draw the brackets anywhere. They're just showing different ways to make up the shaded area. So in this case, we have these 2 purple brackets. So the question is, what is happening here and what is happening here, and how do we put them together? So here in the first purple bracket, we have these 2 pink squares. Each of them, remember, is 1/6. So together, they are 2/6. And over here at this purple bracket, we have another 2, 1, 2. So we have another 2/6. So again, the first purple bracket covers these 2 pink squares. And remember, each pink square is 1/6. So we have 2/6 here. The second purple bracket also has 2 pink squares. So there's 2/6 there. We add those up, we get 1, 2, 3, 4, 2 plus 2, 2/6, and 2 more 6, 4/6. Now, this is a super important and exciting point. Those of you who may understand fractions, maybe you're a little bit more advanced, you're like, oh, that's so obvious. If you're not as advanced, maybe it's a struggle, and that is great and good too. But here's why we're doing this. Many of you may, I'm going to speak to the adults now, you may remember learning in school that when you add fractions, you have to have the same denominator, and then you just add the numerators. That is the rule, but we want kids to understand why is that the rule. And it's because we're adding these like parts. The like parts, that's the denominator. So it wouldn't make any sense to add up 6 and 6 to get 12, because we're not talking about 12ths here. We're talking about 6ths. We have 2 of them here and 2 of them here. So together we have 4 of them. And so to all the kids out there, I want you to understand that is the important part, that we are adding up these individual pieces called 6ths. And we have 2 here, 2 here, and together we have 4. So it wouldn't make any sense to add up the denominators. That helps you understand actually what we're doing. All right, we are almost at time. Holy moly, that was fast. I had a lot of fun. I hope you guys had some fun. If you had technical issues, we'll try to figure them out. I'll figure out how to do the question and answer thing tomorrow. I'll learn, you'll learn, we'll figure this out together. Before you go, every day I will leave you with a brain teaser. So here is today's brain teaser, if I can make this work. This is one that I love. Okay, here it is. You have 9 dots as they are on the screen. I hope folks can still see this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's the goal, is to draw a line, 4 lines straight lines to connect all the dots, and you cannot take your pen or pencil off the paper. So you can't go 1, 2, 3. No, they have to be connected. You cannot take your pen or pencil off the paper. So 9 dots just like this in a square, 4 lines. You cannot take your pen or pencil off the paper. Try it out tonight, and I'll show you the answer tomorrow. All right, have a good afternoon, everybody. Thank you. Bye.